Long after your heart stops beating, long after our oceans boil away, and billions of years after the sun finally swallows the Earth, a piece of 1970s hardware will still be out there, carrying our ghost into the pitch-black void. It was originally built to take some photos of a few neighboring planets, but today it has transformed into something far more profound: humanity's eternal drifting tombstone. It is the farthest, fastest, and most isolated object our species has ever created. Welcome to Astro Trivia. Today we are following Voyager 1 on its chilling, one-way journey to the very end of time itself. To understand how a machine with less computing power than a modern smart bulb made it this far, you have to understand the cosmic lottery we won in the late 1970s. For the first time in 176 years, the outer planets, Jupiter, Saturn, Uranus, and Neptune, aligned in a sweeping arc. This geometrical miracle presented NASA with a once-in-a-lifetime opportunity, a grand tour where a single spacecraft could visit multiple gas giants, using the gravity of one planet to slingshot itself to the next. Launched in the late summer of 1977, Voyager 1 wasn't just flying, it was falling upward, riding the gravitational currents of the solar system. By 1979, it arrived at Jupiter, plunging into a magnetic radiation field so intense it threatened to fry the delicate electronics. But Voyager survived, and the payoff was spectacular. It didn't just give us stunning, turbulent images of Jupiter's great red spot. It completely shattered our understanding of the cosmos when it looked at Jupiter's moon, Io. Before this moment, scientists assumed moons were dead, frozen rocks. Instead, Voyager 1 captured active volcanoes erupting hundreds of miles into the Jovian sky. It was the first time we had ever seen active geology on another world. But Jupiter was just a pit stop. Stealing a tiny fraction of the gas giant's orbital momentum, Voyager 1 accelerated towards Saturn, arriving in 1980. We had always known Saturn had rings, but through Voyager's mechanical eyes, those rings were revealed to be a chaotic, mesmerizing ballet of ice and rock, guided by the gravitational tugs of hidden shepherd moons. However, the ultimate planetary prize was Titan, Saturn's largest moon. Astronomers knew Titan was massive, but Voyager revealed it was cloaked in a thick, smog-like atmosphere of nitrogen and complex hydrocarbons. The atmospheric pressure at the surface was even heavier than Earth's. It was a primordial soup, a frozen time capsule of what our own planet might have looked like before life took hold. Studying Titan was so crucial that scientists made a monumental sacrifice. To get a close-up look at the smoggy moon, engineers had to alter Voyager 1's trajectory. This new path flung the spacecraft sharply out of the orbital plane of the planets. The grand tour was officially over for Voyager 1. It would never visit Uranus or Neptune. Instead, that sharp gravitational turn from Titan aimed the spacecraft toward a new, terrifying destination: the dark, uncharted waters of deep space. It traded a planetary tour for immortality. From that moment on, its mission wasn't just about exploring our neighborhood. It was about leaving it entirely, embarking on a cold, silent journey into the interstellar medium. Knowing this machine would outlive us all, visionary astronomer Carl Sagan and his team made a profound decision. They turned Voyager into a cosmic message in a bottle. Bolted to the side of the spacecraft is a 12-inch, gold-plated copper disc known as the Golden Record. It is a meticulously curated time capsule of who we were. Etched into its grooves are the sounds of Earth: a baby crying, wind howling, a heartbeat, the haunting songs of humpback whales, and musical masterpieces ranging from Beethoven to Chuck Berry. It carries greetings in 55 different human languages, alongside 115 encoded images depicting our biology, our architecture, and our ecosystems. But perhaps the most striking feature of the Golden Record is its cover. It features a cosmic map, a "You Are Here" sign, using the precise locations of 14 rapidly spinning pulsars to pinpoint our tiny solar system in the vastness of the Milky Way. It is a set of directions home, designed to be readable for billions of years, just in case someone or something ever finds it. Before Voyager 1 fully surrendered to the endless night, Sagan made one final poetic request. On Valentine's Day in 1990, roughly 4 billion miles away from the Sun, engineers commanded the spacecraft to turn its cameras backward for one last look at the neighborhood. It captured a mosaic of the solar system, a family portrait of the planets. But one frame stood out above all the rest. Suspended in a scattered ray of sunlight was a single pale blue pixel. That tiny, seemingly insignificant dot was Earth. As Sagan famously observed, every human being who ever lived, every king and peasant, every creator and destroyer, every empire and every single ideology in human history played out entirely on a tiny mote of dust suspended in a sunbeam. It was a deeply humbling visual gut punch for humanity. It reminded us of the extreme fragility of our existence in an otherwise massive, uncaring universe. Shortly after capturing that iconic, haunting image, Voyager 1's cameras were permanently powered down to conserve vital energy. Its days of seeing were officially over. From then on, it would fly blind, relying entirely on its remaining sensors to feel its way through the dark void ahead. Flying blind didn't mean flying aimlessly. Voyager 1 was rocketing outward at a staggering 38,000 miles per hour, about 17 kilometers every single second. At that mind-bending velocity, it was hurtling toward a massive, invisible boundary that encloses our entire solar neighborhood, the heliosphere. Think of the heliosphere as a colossal cosmic bubble. Our sun is constantly blasting out a stream of charged particles known as the solar wind, pushing outward in all directions and inflating a protective shield against the harsh interstellar medium. This solar bubble shields Earth and the other planets from the galaxy's deadly, high-energy cosmic rays. But eventually, the push of the solar wind loses its strength. It meets the immense pressure of the interstellar medium, creating a turbulent, invisible border region called the heliopause. Crossing the heliopause isn't like passing through a physical toll booth or a brick wall. There is no line drawn in the vacuum. Instead, Voyager 1 had to feel its way across this threshold. For years, scientists on Earth watched the data streaming back, waiting for the signs of a transition. The environment around the probe became incredibly chaotic. The charged particles from our sun began to drop off, while the relentless pressure from the galaxy outside began to push back with increasing ferocity. Then, in August 2012, history was quietly made. The instruments on board registered a sudden, dramatic plunge in solar particles, accompanied by a sharp, undeniable spike in galactic cosmic rays. After 35 years of flight, Voyager 1 had officially pierced the cosmic bubble. It became the very first human-made object to enter the dark, uncharted waters of interstellar space. It was a profound milestone for our species. We had finally touched the void between the stars. The solar wind, which had bathed the spacecraft since the day it launched from Florida, was gone. Voyager was now bathing in the ancient plasma of the Milky Way, particles that had been forged in the explosions of long-dead stars millions of years ago. It had successfully escaped the domain of the Sun, but it was now facing an entirely new, terrifying reality: the sheer, unimaginable scale of the galaxy and its own slowly dying heartbeat. The sheer distance is almost impossible for the human brain to comprehend. As it crossed this invisible threshold, Voyager 1 was billions of miles away from home. At this unimaginable distance, our massive sun had shrunk to just another bright star in the blackened sky, offering virtually no warmth to the freezing probe. It was truly alone. Yet, despite this extreme isolation and the brutal cold, the spacecraft was dutifully continuing its scientific mission. It kept whispering its revolutionary findings back across the vastness of the solar system, transmitting faint signals to the pale blue dot it left behind so many decades ago. Today, Voyager 1 is over 15 billion miles away from Earth. To put that staggering distance into perspective, if you were to send a command to the spacecraft right now, traveling at the absolute speed of light, it would take nearly 24 hours just to reach it. And you would have to wait another 24 agonizing hours just to hear a simple acknowledgement back. It is a slow, agonizingly delayed conversation across the cosmic ocean. But that conversation is rapidly coming to an end. Voyager 1 operates on nuclear power, specifically utilizing 3 radioisotope thermoelectric generators, or RTGs. These generators cleverly turn the intense heat from decaying plutonium-238 into electricity. But physics is relentless. As the radioactive plutonium naturally decays over the decades, the power supply steadily drops. The spacecraft loses about 4 watts of electrical power every single year. Because of this fading pulse, NASA engineers have been forced into a heartbreaking routine of interstellar triage. To keep the core systems alive, they have had to permanently turn off heaters, power down redundant systems, and slowly shut off the very scientific instruments that made the mission legendary. It is like watching a freezing traveler slowly lose sensation in their fingers and toes just to keep their heart beating a little bit longer. Sometime in the coming years, perhaps within this decade, the power will finally drop below the critical threshold required to operate its main transmitter. When that fateful day inevitably arrives, there will be no explosion, no dramatic final malfunction. From our perspective on Earth, Voyager will simply stop talking. It will go entirely silent. But the physical machine will not stop. Free from the gravitational grip of our sun, it will continue to coast through the void at 38,000 miles per hour, completely blind and deaf. In about 40,000 years, long after human civilization might have fundamentally changed or vanished entirely, this silent, dead spacecraft will pass within 1.7 light years of a red dwarf star known as Gliese 445. No one on Earth will be tracking it. It will simply drift past, a ghost ship carrying the golden memories of a world that may no longer exist. Once Voyager's radio dies, the scale of its story fundamentally shifts from human history to cosmic eternity. Fast forward about 4 billion years, our sun will have swelled into a massive red giant, likely swallowing the Earth and violently erasing any trace that we were ever here. But Voyager 1 will still be out there, safely distanced from the fiery death of our dying star. Around this same time, it will silently witness the most spectacular cosmic event in the history of our neighborhood. The Andromeda Galaxy, currently rushing toward us, will violently collide with our Milky Way. For billions of years, immense gravitational forces will tear these two colossal galactic structures apart, violently mixing hundreds of billions of stars in a magnificent cosmic dance to form an entirely new, massive elliptical galaxy. From Voyager's isolated perspective, the sky will be completely unrecognizable, ablaze with the chaotic birth of new stars and the merciless destruction of old ones. But jump forward again, this time by trillions of years. The universe will begin to exhaust its finite supply of usable hydrogen gas, the very fuel that brings light to the cosmos. Star formation will slowly grind to a permanent halt. The massive, bright blue and white stars will have long since detonated in brilliant supernovas or collapsed into black holes. The only stars left will be the tiny, slow-burning red dwarfs. Eventually, even these resilient little stars will burn through their remaining fuel and fade to black. The universe will then enter the degenerate era, a dark, freezing expanse populated only by the dead remnants of stars, white dwarfs, neutron stars, and hungry black holes. The night sky will go completely pitch dark. The cosmos will become unbelievably quiet. If Voyager 1 has somehow avoided colliding with a stray asteroid or being swallowed by a rogue black hole, the tiny probe will now be older than almost everything else left in the dead galaxy. But even Voyager cannot outlast the fundamental laws of quantum physics. Move unimaginable timescales into the theoretical future, and we reach the bizarre era of proton decay. Physicists theorize that eventually the very subatomic particles that make up ordinary matter will lose their inherent stability. The structural building blocks of reality will fail. Atoms themselves will begin to literally come apart at the seams. If this prevailing theory holds true, Voyager's gold-plated record, its sturdy aluminum chassis, and the frozen, dead remains of its nuclear heart will slowly begin to dissolve. Over incomprehensible eons, the spacecraft will evaporate into a faint mist of lighter subatomic particles, radiating softly away into the infinite, freezing dark. The ultimate cosmic survivor, the last physical fingerprint of humanity, will finally be erased from existence. Until that incomprehensibly distant day, Voyager 1 presses onward. It is no longer just a triumph of engineering. It is a permanent monument to our most defining human trait, our insatiable curiosity. Against impossible odds and unimaginable distances, we looked up at the terrifying, beautiful void, and we bravely reached out. Thank you for taking this cosmic journey with us here at Astro Trivia. If this deep dive into the far future shifted your perspective, hit that like button, share this video, and subscribe to Astro Trivia for more mind-bending space exploration. Keep looking up, and see you next time.